Back to Algebra with Miss Swartz. Today we're continuing on with our compound inequalities, but we're looking at absolute value inequalities. We use compound inequalities within the absolute value inequalities, which is why we covered compound inequalities first. So I want you to think back to when we did this, okay? What this meant was the distance between x and 0 was 1. Okay, so we're going to look at absolute value inequalities in the same light. Okay, so let's start here. You can write this down. I'm going to try to make it longer here, maybe. Sorry about this. Let's try to scroll this. No, it's not working. I'll move these up. Okay. So what this says here is the inequality, the absolute value of x is less than 2, means the distance between x and 0 is got to be less than 2. So if I were to graph that, okay, so I have -4, -3, -2, -1, 0, 1, 2, 3, and 4, okay? The distance between whatever number I have here needs to be less than 2. So could one of my solutions be -3? Well, is the distance between -3 and 0 less than 2? No. So I only want to shade spots that are less than 2. So 2 could be a solution, but in this case we want it to be less than, so we're going to have an open circle at 2. And we could shade anything in between here all the way up to 2, right? Because if I start heading this way, or right of 2 here, the distance between 2.5 and 0 is bigger than 2. So for this to be true, this has to be my graph. So the graph of the absolute value of x is less than 2 is the graph of this. Okay, notice this word in here. And so how we could write this would be okay, or another way. So you will see that when we have an absolute value inequality that has less than, we're going to be looking at an and compound inequality. So let's look at the next example. If we have an inequality that has an absolute value that's greater than 2, it means the distance between x and 0 is greater than 2. Okay, so let's look at that on a graph. Well, so again, it's not including 2. But now we're looking for numbers that are greater than 2. Well, anything in here is not greater than 2, the distance from 0. But 2.5, 3, 4, 5, they are all greater than 2 when we're talking about the distance from 0. So we'll shade on both sides of the graph because the distance of -3 from 0 is 3, so that's greater than 2. So the graph of the absolute value of x is greater than 2 is the graph of x is less than -2 or x is greater than 2. So these are important things to understand because this helps us break apart our absolute value inequalities. When we have less than, we're going to see an intersection. Or another way to put that is an and inequality. When we have greater than, we're going to see a union. Or another way to put that, an or inequality. So we need to be able to write those how they are. Notice when you're talking about or, our arrows are heading opposite directions. If we look back, we're talking about and. Our arrows are actually heading towards each other in this case, okay? They're heading in the same direction. That's our and. So let's look at some examples. Well, first let's look at this core concept. This will be in your journal. So you don't necessarily have to write all of it, but it might be really actually beneficial to write this down. What I want you to write down is this. To solve this, okay, so whatever you have inside the absolute value, whether it's x or 5x or 5x plus 1, okay, if it is less than c, okay, we're going to break it into two parts. We have ax plus b is greater than negative c. So flipped your inequality and you now have a negative number. And then you have this other piece, which would be ax plus b is less than c. Okay, so then the opposite of that, if ax plus b, the absolute value of ax plus b is greater than c, now we're looking at an or inequality. Okay, so again, flip your inequality and we're talking about a negative c, and then keep it the same. Okay, less than is and, greater than is or. That's important that you that's a memorization thing that you'll have to do. So let's look at examples. All right, our first example, A here, we have x, the absolute value of x plus 7 is less than or equal to 2. Okay, so first thought in my head is it's less than. So what type of compound inequality is it going to be? Less than. It's going to be connecting because those numbers are going to be less than 2. So this is going to be an and inequality. So my graph should reflect that. I got to be able to think about that. So I'm going to write two inequalities here. I'm going to keep the same, right? X plus 7 is less than or equal to 2. And then I'm going to write another inequality. I'm going to flip my symbol, and I'm going to have a negative 2. Okay? So notice if they're and, these are heading in opposite directions, and that's kind of what we want. So if we subtract 7 on this one, we got x is less than or equal to negative 5. Subtract 7 here, and x is greater than or equal to negative 9. Okay, now if I go to graph this, negative 10, negative 9, negative 8. Okay, close circles at both. Think about this. X is greater than or equal to, so that's going to be heading this way, and x is less than or equal to, so that's going to be heading this way. I have an and, so it should be an intersection. So I could also rewrite this. We like to put the smaller number first. So 9, negative 9 is less than or equal to x, which is less than or equal to negative 5. Notice here you can see them going in the same direction, which is why we like to write the negative, the smaller number first. Okay, so look at B. B is also less than. So this is again going to be an and compound. So we have 8x minus 11 is less than 0. And then we have 8x minus 11 is greater than, well, 0 can't be negative, so we're just going to write another 0. So I'm going to add 11 to both sides. So 8x is less than 11. Divide by 8. So x is less than 11 over 8. Or 1, and you can change it to 1 3/8, whatever you see fits. Okay, so if I add 11 to this side, x is greater than 11 3/8. So think about this. Could x be less than 11/8 and greater than 11/8? Is that possible? No, it's not. So this is no solution. And you could see this up here, because for this to work, your inequality, your absolute value inequality needs to be at least bigger than or equal to 0. So if this said equal to 0, we could maybe talk. okay? But since it's less than 0, okay, it's not going to work. So here we have no solution. So even if you get to this point and you're thinking about that, you're thinking about how I would graph that, how could you graph x being less than 11/8 and x being greater than 11/8? If it was equal to, we could at least graph 11/8. That could be a solution. But since it's not, nothing works. So no solution is our answer. Okay, so let's try A here. We have C minus 1. Now we have a greater than, so we're going to keep 1 the same. Always keep 1 the same. Greater than is going to be an or inequality. So then we also have C minus 1 is less than or equal to -5. And then we flip the inequality and change the second number to negative. So I'm going to add 1 to both sides. So we have C is greater than or equal to 6. And C is less than or equal to -4. So when I graph this, they should be heading in opposite directions. Okay, so I have a closed circle at 6, and C is greater than 6. And I have a closed circle at -4, and C is less than -4. So that is correct. Because remember, what this is saying is C minus 1 needs to be a greater distance than 5 away from 0. So all of these would be a greater distance than 5 from 0 when I figured out whatever this is inside here. Okay, so go ahead and try B. We also have an or problem here as well. So try that one on your own. Okay, so this one's getting a little lengthy, so I'm going to do one more of these. We're not going to do this one today. You're going to try that one, and we'll call it good. So this is an and, okay, because it's less than, so I'm going to write one that's exactly the same, and one where I flip my inequality and use the opposite. So I'm going to add 3 to both sides, so k should be less than 2. I'm going to add 3 here, so k should be greater than 4. Okay, so remember they should run into each other. Okay, so I have an open circle at 2, and k is pause this. Made a mistake up here. So this should actually be 2 as well. So again, we can stop ourselves as I make my mistakes in my video. Can k be less than 2 but also be greater than 2? No. So look here. And maybe you caught this before I did, as I'm just trying to work through these problems. But can an absolute value, anything inside an absolute value, be less than -1? That would make anything inside here less than 0. You can't have absolute values less than 0 because absolute values are not going to be negative. So here, again, you would have no solution. So excuse my mess that I made here, and do better than I do. Okay, so go ahead and try number 3. When you are done with that, I'll take a peek. I know this got a little long. Your homework is actually going to be in your textbook tonight. Quick few problems here. Page 91 in your textbook. It's important because we haven't done a lot of textbook work yet. 3 through 10. Okay, so it's just a few problems today. 3 through 10. That's actually not due till Monday because of map testing, but remember, things can go wrong, so just be prepared. Okay, have a great day.